In this video, we will show you the project developed by the students of the fall 2025 semester of the Mechatronics class from the University of Texas at El Paso. Our project was developed based on the following quote: "Saving time helps save lives." The objective of this project was to design and build a medical assistant rover which is able to operate in reduced spaces and is also able to centrifuge blood on the go, meaning it can go from point A to point B, helping staff reduce time of waiting while ensuring easy handling, safety, and reliability. Our project is made up of three separate systems. The main system is the rover, which has the following components: a line following sensor, an ultrasonic sensor, and gear motors. We also developed this project using an Arduino Uno R4 microcontroller for IoT control. Next, we have the centrifuge, which is made up of the TFT LCD display screen, an encoder to control the RPMs of the centrifuge, and a Lego Mega R3 and DC motor. And last but not least, we have our lockbox. It is made up of an LCD display, an Arduino keypad which helps secure the lockbox, a servo motor, and an Arduino Uno. The rover works in the following way. The first thing it would do is with the ultrasonic sensor, it will check for obstacles. If there is an object detected within 15 centimeters of distance, the rover will stop. If it is not, it will continue, and the next thing it will check for is the room signal. If there's a signal call from the application that we made with IoT Control, then the rover will stop once it reaches the door. If it's not called and there's not an object in the way, the rover will continue and the line following sensor will check for the black colored line. The centrifuge works in the following way. It is important to know that the user can see all of the values displayed in the LCD display. Once the centrifuge is initialized, the user can set the desired RPMs and the timer for the centrifuge to run. Then, it will check if the user called the start button or if it didn't. If it didn't, it won't run. If it did, it will run for the set time that in the set RPMs. Next, we have the lockbox. Once all of the components are initialized, it will check if a code was input. If the code was input incorrectly, then it will prompt the user with a message of a wrong password on the LCD display. If it was input correctly, then it will rotate the servo 90 degrees and wait 10 seconds before returning it back to the start position. This allows the user to take things out of the box or put items on the box in a determined amount of time. And finally, we have our finished project. In this part, you can see how the user is inputting a code, and you can also see the servo rotating the 90 degrees, allowing the user to open and close the door. Once the servo goes back to the start position after 10 seconds, the user no longer can open the door. This is what the user interface looks like. The user can access this interface via IP address. In here, the user can call the rover from either door 1, 2, or 3. After the rover is detected by the ultrasonic sensor, it will start a clearance time which is 15 seconds. After those 15 seconds, the rover will go back to running and it will only stop if it's called by a door again or it detects an obstacle. In here, you can see the third door is being called. Over here, we focus on the Arduino microcontroller and how it's gonna flash after it detects the rover. In here, you can now see how the 15 seconds of clearance is being activated. Now, the user has 15 seconds to either run the centrifuge or open the lockbox. And now, we would demonstrate that our rover also works while centrifuging blood on the go, which is the main objective of this project. We also see the rover stops after it detects an obstacle on its way. Our project successfully demonstrated how automation can simplify and speed up routine medical tasks. Since it is designed to transport and centrifuge blood on the go, the rover helps medical staff save valuable time that would otherwise be spent walking between collection points and laboratories. Our project showed how embedded systems and mechanical design can come together to solve real-life problems in healthcare environments. It also showed us the importance of efficiency, safety, reliability, and teamwork in engineering.